or if you guys are watching delayed, I'm going to be making one of these oscilloscopes, DIY kits, and it's just mostly all soldering. But I've had it sitting for over a month, and probably time to do this. Currently, I'm streaming just through my phone. I was waiting for a bit since you need 1,000 subscribers, and it was at the beginning of May that I did hit 1,000 subs. Again, thank you to everybody. But it took almost a whole month for me to be able to stream through my phone. So it was a little weird. But here's these kits. Let me open it up completely so you get a better idea of what it is. And so, dropping it all out, you have a PCB, all the components, and a schematic here. And the reason why I'm making this little oscilloscope is because originally I wanted to buy an oscilloscope, but they're extremely expensive. So I wasn't willing to spend too much money, and I watched a Great Scott YouTube video, and he bought one of these and went over it, and it seemed pretty neat for the price. This one I paid $25 just from Amazon, and I got all this stuff. So yeah. So here's a schematic. Hopefully it doesn't take that long. And from here it looks like it's a lot. But I'm not too sure what this is. Another schematic with all the quantities. I needed this oscilloscope just to be able to see the data for some LEDs that have the microchips on them. Let me pull them out. I think I have them here. So here they are. They're addressable LEDs, and I can't really, you can see the little black dots inside the little modules, and that's actually a microcontroller. And the microcontrollers all communicate together through on and off datas or bits. And so with this oscilloscope, hopefully I can read those bits. But this is also really good at learning tool to figure out like how to make PCBs, because currently I don't really know all that much about it. You can see the main components. I'm guessing this is some kind of voltage regulator. The main microcontroller here, and not sure about this, probably an op amp or something. Let's see what else. There's one more piece of paper. Alright, this one is once everything's built, I'm assuming. Unless it's... Alright, so it says all the resistors. Oh, this is pretty cool. You got a little checklist. So you just check it off as you go. Or you can you go bit by bit through all of this. But yeah, pretty cool. Again, hopefully it doesn't take too long. If it does go for too long, I'll just keep going. But yeah, let's open this up. Guessing people are now joining. For everyone who's here, feel free to ask any questions. these, I plan on streaming more. Originally, when I first started uploading videos, I had like one stream, and I didn't keep streaming just because this is technically like my year off of school and also work. So I just wanted some like time off and just do all this stuff for fun. But from doing that, I have like no schedule. So hopefully by streaming a lot, it gives me more of a schedule and I can do like more videos and just learn a bunch of more stuff faster. But if you see here, this is the door design that I'm working on, and it's not that great. You can see pushing it back, there's like no give, but pushing it forward this way, there's like a lot of give. And it has the gears on the inside. So here's the gears for the door. And over here, opening this up, there's a micro servo with a little gear here. And so turning this, it's a little tough, but it turns with the servo. I need to reprint a different design that has a support over here. And hopefully that'll make it a lot better. But for right now, this is all I have. And it's pretty janky as is. So it doesn't really work. But the door design's there. It also has just a little curve here. And that's so if a block is next to it and it turns, it doesn't interfere. So there's that. Just put it in there. Oh, it looks good. Thank you. One thing, there's a couple things that's kind of off. And it's because of the way I printed it. And so I printed it this way. If it was printed this way, I could get away with having this little door design here on the other side. But you can see that it's not too good of a print here. And also these supports didn't come off. They're just like stuck there. So I was looking at being able to print it this way, and it seemed to be like the same amount of time that it took printing it this way. So I may do a different way, but I'm not too sure because it is 3 hours of printing. So I'm not sure if it's too worth it. Let's see. I don't even know where to start. It says to start with the resistors. So these aren't marked. Neither are these. Let me check if these are the same values. Yeah, it looks like they're the same values. You can tell by the, what are they called? The little lines. And all the colors seem to match up. Here I have, these aren't resistors, these are inductors. And you can tell because they're green instead of these resistors, which are blue. I bought some inductors thinking that they were resistors a long time ago. But yeah, I didn't understand the difference. Basically, the difference is that the inductors are just like an electromagnet wrapped around the ferrous material. And so they're marked in henries, and the resistors are in ohms. And the resistors are basically like just graphite. And so there's resistance just like that. It's a random guy. So we got some diodes. Oh man. These, I'm not too sure what they are. I think they're inductors also. So you see, they probably have the core on the inside and the wire wrapped around. We got capacitor, electrolytic, We got the little 9 volts in. I'm pretty sure this is a capacitor, but it's a kind of capacitor. It's a variable capacitor. So you can actually tune the capacitance. I didn't know that, but before doing this, like I searched up what this symbol was. That I was able to look through the bag. Where'd it go? Up here. And so basically, it looks like 2 plates with T that's sideways. And so the 2 plates is a capacitor, but if it has that T, then the T means that it's a variable capacitor. And there's also one that's an arrow, and the arrow means that um, it changes capacitance through other types of things. So you don't set it, it's like through the current or something. This is an oscilloscope soldering kit. It was like $25. And so what an oscilloscope does is just like a voltmeter. It'll show you the volt values on this little display. And so it'll do the frequency. And what the frequency means is that like a sine wave or an AC or alternating current, what those do is that the voltage changes, then it drops to negative, then goes up, and it continuously changes that like that. And so the alternating current is what's used in like homes for lights and all that stuff. Or to more like it's more efficient to send to your home than direct current. And what direct current is constant voltage. So that's just a line. And so that'd be like 9 volts, just a line straight across, since there's no alternating voltages. It's just one straight line. But with the oscilloscope, you're able to see the frequency of the alternating current, and you can also see data. And since data is just a bunch of ons and offs, and so you're going to be able to see on states, it dropped, and on, just like that. So they're pretty cool. And this one's really cheap. The big oscilloscopes, they go like almost $1,000 or something like that. I can't remember too well. Maybe I think they were $100. The really good ones are like $1,000, but you can get like with power supplies, you can get tinkering ones that are less expensive. And this one's like super cheap, just $25, and probably good enough for what I need for. Yeah, I really don't know where to start. We're gonna get the resistors. So yeah, I need to check what the resistance is for each of these. There's also a lot of other resistors scattered around. So this is gonna be a little tough, just a little bit. It's all right. Let's see. Yep, all these resistors have different values. The way the schematic works is that for each individual component, where to be soldered, it's marked C for capacitors, it's marked R for resistor, and it'll say R1, say R2, R3, and in order to figure out which resistor to put in, as over here, what R1, R14, R16 are, just 100,000 ohms. And so just going little by little, you're able to build up the schematic in the full circuit. It'd be pretty easy just to get the big components on, but I don't want to like make a mistake where I have like no more space to work with. I think the main thing is finding all the resistors and then just separating them out, making sure that they're those values. I have this multimeter that's analog, and it's pretty cool, but the resistance metering isn't all that great, but hopefully it'll be good enough for this. Sometimes it's off by like 2 marks or something on here. Let's check this one. It's not marked. This one is extremely high resistance. Oh, I can't even read that. This one might be a 2 million. Oh, and there's a 1.8 million. That one's gonna be tough. I'm gonna have to do that by looking at the marks on it to figure out which one is a 2 million and which one is the 1.8 million. We'll just set that aside over here. This one, I also can't read. Let's see if there's any. Oh, this one I can read, hopefully. And make sure this is set good. With this analog one, you're able to, oh, hold on. How do I bring back the chats? All right, there we go. You see wires and poggers, lots of wires. All right, over here, there's a little side for ohms adjustment. And so what the adjustment is, it has 2 different settings. So you have a lower setting here of just like 1 ohm, 2 ohm, and all that reading. But then you can change it to multiplication of 1,000. And so after that, you have to adjust it down to 0. And here I'm touching the 2 leads. So there's a reading of 0 ohms. Once it's set to 0, I can read the other resistors that have a higher resistance. This one looks like 10K. There is one 10K, there is a 20K. There's no way this one's 20K. So this one's for sure gotta be the 10K. All right. I'm gonna set that over here and mark it. Put 10K. Yeah, this was a lot more work than I was expecting. I was expecting these to be already labeled. This one might be, let's see, let me get this up here. This one might be 200. Let me get all the big ones first, and then just set aside the smaller values. This one has 3, so this one's either the 100,000 ohms, 120, or 1,000. And this one's the 1,000 ohm. Oh wait, no, that would be like 100. 120 maybe? That one has 3. All right, I'll set those aside too. Let me try and find the big value ones. Let's see, this one. Ooh, that one's the big one. This one has 3, so definitely not 100,000. Not 1,000. Oh wait, actually, this one might be the 100,000. There's a 10,000, not that one. I'm guessing this one is, oh, the 120? No. Take it easy, Osman. Thanks for dropping by. I think this one might be the 100,000. Doesn't look like it can be anything else. I will set this one over here. Let's check this one. That one looks like 20,000. And there is one 20,000 ohm resistor, so this one is the 20,000. Put this one right next to 10,000. All right. This one looks like almost 2,000. And we have a 1.5 thousand. Looks like this one's 1.5 thousand. Yep. All right. Let's see what else we got. All right, here we got, this one is really low. Set that one aside. Over here. This one's 500. Maybe. I see 300. So this one might be 300. Measure that later. So the way I'm able to find out what the resistance is that the multimeter has a built-in battery. And so it's allowing the current to flow through the resistor. And inside the actual multimeter is another resistor. And so it forms a voltage divider. And based on that voltage divider, it moves the arm with a different current. Different current and voltage from that divided voltage. And so that's what you see when it moves. This one's another lower. Let's see if there's any more higher value. Luckily, it's only the resistors that are kind of hard to figure out. But the capacitors have the marked capacitance. So that'll be easier. I haven't seen a 3,000 ohm. This one's also tough. Looks like 2,000. We already marked one that was a 1.5 thousand. So there are no other ones that are in that range. The only other one is 3,000. Put that over here, just in the unknown. Probably separated. Let's see, anything? We got one more. We have two more, I think. This one's a super high one, 100,000. There's one that's 200,000. So yeah, this is really bad. I think it's because of the multimeter. Take it easy, Abraham. Thanks for stopping by. I have one other multimeter. Might be better. Let's see here. Got this one's like 1,000. This one might be the straight up 1,000 ohm resistor. There's three of them, but it's marking it as higher than 1,000. So I'm gonna definitely go grab the other multimeter. So I'm gonna be right back. All right. So I grabbed this other one that I have just lying around. It's a digital one, so it should be able to read the resistors better. So I'm gonna set it to 2,000. I think that should be good. Oh, it's very slow. Pretty slow. All right, let me get these wires untangled. So hopefully I can get standing. This one's neglected. It just is outside. So here you go. There you go. Let's see if I have any other ones. All right. Let me try these that are in the middle. Just can't read this one. Might be too high. There you go. It's at a 20K. I think that means you multiply it by 10,000 though. So this one would be a 3,000 ohm. 30,000 ohm. Right? Or just 3,000. It's looking like it might just be 3,000. since there is no 30,000. So this will be 300. All right, let me use a known resistor just to make sure I remember how to use this. We got, all right, I got this resistor kit. So it's got a bunch of resistors, just all labeled. Grab a 100,000 ohm. See what this is about. So now if we test it with a known resistor, get a better idea of what the markings mean. Okay. So we know this one is a 100,000 ohm resistor and it's marking 0.1. So if I bring it back, we'll do the 2,000. That means it should be marking 1, right? Ah. Is that 100? What if it's at 200? Okay. So 100, and then you multiply 1,000 right here. 100, wait a minute. 100.6. 100.1. Oops. 0.1. That one doesn't show it. What does it mean? The numbers, what do they mean? So that one's at 100. And oh, did I grab the wrong ones? All right, that's my bad. These are 100 ohm resistors, not 100,000. So that means this should be showing 100, if I remember right. All right, that's my bad. Yeah, so that one measures 100. Not 100. This one measures. That one also measures same, 100. This one measures as 0.1. And so divide or multiply that by 1,000 and you get 100. All right, let's try this again. Multiply that by 1,000 and you get 300. So this one is 300 ohm. Put it back here. Doesn't read it. 2,000. There it is, 300. Is there 300? Yeah, there is. So this one, put it over here. Mark it as 300. Let's see. All right, now we're cooking. Now we got this. This is a lot easier. So now let's check this out. This one not able to read it. Lower it maybe. Probably raise. Yep. All right. Here we got, looks like 10. So multiply that by 1,000, that's 10K. And there are two 10K resistors. Okay, we already marked one of the 10Ks. I'm gonna double check the other 10K just to make sure. This one is a 10K. A little bit lower. But 10K. All right, this one over here looks like 3K. So there's our 3,000. This over here, market 3,000. All right. Over here we got 400, 500. Do we have? Oh, we have a 470. So we have two of these. I'm gonna find the other one. 470. Might be this one here. Let's check it out. This one looks like 180. I don't see any 180s. 200. Yeah, I don't know what this one is. I'm just gonna set that aside. We have these higher value ones. We have this trio one. Let's check this out. 120. All right, cool. We got 120. Just set that there. Let's check these trios. This one's 1,000. We have 3,000. All right. Let's try this one more time. 0.4. 0.47. All right, there's the second one. This one over here was a odd one. And looks like 180. There is no 180. Let me drop it down. Yeah, it's still marking 180. Maybe it's just a wrong one. Let's see, looking down the list. Oh, there is 180. Okay, there's two 180s. Let me put that here. So we need to find the other 180. I have two over here. This one, oh, these are both the super high resistance ones. 2,000. This one's 300 million, maybe. What's it? So we had one that's 2 million and one that's 1.8. $140. Maybe it's. Oh, that is way different. My fingertips were influencing it. This one I can't read. Let's drop this. Oh, not that much. Still not reading. 1.8 and 2 million. Those are the highest value ones. This one, it just jumps all over the place. Well, we're at 200,000. Nope. So that one might be the 1.8 and the other one might be the 2. Other than that, let me check over these that we have marked. Let's see. I'll mark them and I'll highlight them, and then that will make it easier. So right here for the 10K, we have 2. Yep, we have both of them. So we'll highlight that. 470, we have 2. 1.5, we have 1, 2. Nope, just 1. 3,000, we have 1,000. Yep. 120 we have 180. We just have one of the 180s. We have the 300. 20,000 we have these 3 100,000 and 200,000. So we're missing a couple. I have 2 of the bigger ones over here at the bottom, and looks like the other 2 are missing. Maybe in the bag. Oh, I found them over here. All right. There's 3 of them still have to test out. All right. So I have these 3. Set this to the lower 20K. This one is 1,500. 1.5. Yep, this is the other 1.5 thousand. We've got this one here. 180. And this last one is a high value one. 200,000. Wait. No. Let me mark these. So we did find the 1.5. Got the 180. 1, 2, 3. We're left with 3 unknown. And I have 3 unknown on the bottom. So it looks like this multimeter might not be able to read those as well. But let's just try it. Hopefully there's a good reading. So this one's set at 200K. That means instead of multiplying by 1,000, we have to multiply by 10,000 now. And it looks like it's marking 200. Well, it was. And then it lost continuity. So I'm guessing this one is the 200,000. Yep, there it is. All right, cool. Move that over. So now there's 2 unknown ones. Almost done. Almost ready to start soldering, probably. This one won't read. That's making me believe that it's the 2 million. So I'll set that as 2 million. And this other one does read, but it reads a little bit low. Oh, that one does read 1.8 million. All right, cool. I think I was just tripping before. So now we have all of them marked up. Just got them all numbered right down here. These are all numbered on the bottom. And we got all these little capacitors. I think I'm just gonna, instead of sorting them out, I'll just start soldering the resistors. And when I start soldering the capacitors, if I pick up the wrong one, I'll just put them all together. And so they should, over time, just naturally be sorted out that way. Let me move all this stuff. And I think get started with soldering. Let's see. We'll get that ready. So yeah, digital multimeter did help out a lot more. RIP to the analog, wasn't able to get those higher value ones. All right. How's it going, Red? This is a little soldering kit for an oscilloscope. So I just marked out all these resistors. Now we're ready to solder. There's no other major things to separate out. Everything else is marked. I'm not sure if these are the chokes. It looks like they are. HF chokes. 100 microhenries, microhenries. Because I don't see any other inductors other than these. Yeah, all right. So I'm just going to be grabbing these one by one and then just putting them all in. And the best way I think to do this is just by inserting them. And once they're through the hole, you just bend them out. And after you have all of them through the pin or through the holes and the bent, then you go soldering one by one all the components. Let's see. Time to do a lot of reading. Let me grab this other reference. This might help. So this one, I don't think this diagram will help too much. It does have the resistor values marked on here, so it'd be easier to check that way. But it'll be simpler just to go one by one, checking this list here. Let's start top left, and I'll go to the right. Just keep going down and to the right. So R4 is a 2 million. So we got this one here. So just bend it, bend the leads, and then straight through the holes. So there you go. We're done. This is an oscilloscope. Good job, guys. We did it. All right. Just bend this out here and here. Got that good. Let's see. We have next up, there's a bunch of resistors here. R26 is the next one that's on the most top. 26 is 1000 ohm. Got that over here. So just bend that out, bend this in. And 26. Right through there. It went in the different hole. There you go. And let me mark them. Get a paint pen. Grab the green one. So 26 and R4. Next up, R37, 10K. Oh man. I don't know which 10K it is. We got 220. How many 10Ks? Two 10Ks. So that one's a 1.5. Oh geez. Alright, found it. Then that. And those leads out. It's the next one. There's a diode. These are capacitors. The L, not too sure what L is. L stands for, LED, number 2. And here, capacitor, diode. J9. What is J9? Pin header. Regulators are U. Transistors are Q. Capacitor trimmer. Power inductor. All right. Going down over here to the left. Capacitor. We got resistor 2, resistor 5. Resistor 5 is resistor 20K, which is right here. Hopefully 20. All right. Resistor 5 is in. Let me double check. So this one's supposed to be 20K marks. 20K. Does it mark 200? Nope, it is 20K. All right. Resistor number 2, 1.8 million. We got that up. All right, there's the 1.8. What else we got? J7 diode transistor. Diode there. Down here, inductor, capacitor, transistor, diode. Oh, this is a resistor. 36. 36 is 36. Where is 36? 180. So here's a 180. Put this over here. All right. The pin's bent. And I'll forget to mark it. We got 36. And we had 200,000 R3. Wait, did we have R3? What? Oh, not 200,000. We had 20,000, which was R5. We had R2. 1.8. So we still need 20? No, we got 20. We still need 200,000. Right, all right, cool. So next up, capacitor, inductor, capacitor, inductor, capacitor, transistor. Down over here, we got a resistor here, 38. 38 is a 1.5. Oh, this one got mixed up. So here I have 1.5. This one is going right in. Where'd it go? Here. 38. All right. Let me check. So we need this one marking 300. It's 3,000. This one is 3,000. So this one is R10. All right, so I see. Need to remove that. Put that one right there. check this value. This one looks like 470. Put that down here. Check this one. 470. Alright, so it has to be this one here. They got mixed up a little bit. 1.5. And 1.5 is one of the ones we need. This one is 38. 38 is right here. Bend the tabs over. And there we go, we got 38 in. So now we can mark that off. One under 38 is going to be 39. For 39, that's a 10K. This one looks like it's 10K. Make sure. Nope. 1.5, this one. This one's reading like 9.7. So I guess it's this one. Reading a little low though. Oh no, it's cool. It's all good. Alright, so we got number 39. And don't know where number 37 went. I feel like we already did 27. I mean 37. We did do 37. It's up here. So we can mark all the 10Ks. Let's see. What's up, Ruben? This is a oscilloscope kit, a little soldering kit. And if you have any questions outside of this, feel free to ask. I want to treat these live streams as more like tutoring, I guess. So if anyone has any questions and needs help, feel free to ask. I'll always stop and answer. What is next? Moving to the left, transistor, capacitor, a ground, transistor, capacitor. Right here we have two resistors. We have R1 and R3. R1 is 100,000. And got those here. Let's see. So we got R1, 100,000. Right in there. R3 is a is that one of the ones we marked off? Is it the 200? Yeah, it is the 200,000. Right here. It's kind of weird, these resistors, they're like cut more on one side than the other. Don't really know why. Kind of weird though. Alright. So now we mark off resistor 1. Hey, Mary. There you go, R1. What else we got? We got a transistor here. going from here. It says R20. Oh, these are already set in. These resistors are called, what are they called? Surface mounting SMD components. So they're surface mounted, which means that they just get soldered onto pads here instead of through a hole like these resistors. All right, capacitor. Oh, here we have a bunch of resistors. So we'll be tackling these down. R14, that's a 100,000 right in my hand. We can get this one knocked out pretty quick. My aim's a bit off. There we go. So there's R14, then it's R13. R13 is 120. Oh, that's one of the threes. So there's the 120. Next is R10. R10 is a 3,000. 3,000 right here. Make sure they're straight so they're easier to go into the holes. Right through there. R10. What's R10? R10 we just got done doing. I got confused because of 3. R9. 1,000. Yeah, that over here. And these done a lot faster having them all in one line. Now we got our 11. That is, I'm blind, 1.5 thousand. This one, maybe? Yes. Our 11 is almost complete. There we go. Our 12 is, I'm blind, 120. All right, sweet. These resistors are like the sketchiest to be doing just because like you get one resistor mixed up and the voltages will just be super different on the oscilloscope. All right. Let me mark these off so I don't get confused. So were these all? We had 9, 10, 11, 13, no, 9, 10, 11, 12, 13, 14. So we got 9, 10, 12, 13, and 11. Cool. Oh, and 14. RIP. 14 there. What else we got? We got some more resistors. We have 15 and 16 right next to it. 15 being 1,000. My last 1,000 is right here. Check this out. R15. That's all in. R16. That is 100,000. Here's my last 100,000. so close. Got 5 left after this one. Come on, come on, come on. Let's go. The baby, let's go. Alright, sweet. What else we got? Let's mark those 15 and 16 off. Done with the 100,000. 16, 15, done with the 1,000. Alright, moving on to the right. R40. What is R40? 470. Here we go. I think I used the 3,000. Yep. Alright, let's see. Is there any other close ones? Doesn't look like it. Got a capacitor, capacitor, capacitor. I don't even know what that looks like. It says Y. What's Y? Y. Why is it like that? Y. Why is the crystal for the timing? Oh, there's 14 here. That's capacitor. 28 is here. 470. Oh, where's the last 470? We have 300 and 180. Oh, we have a 180. I might have lost one of the resistors. Was it 200,000? I think we got rid of the 200,000 ohm. Might be this one. Let me double check. This one is it's supposed to be 470. Yep, it's 470. You got like knocked up here over to the 20K. This one is number 28. Look at the back. Look how the back looks so far. So many leads all over the place. So we're done with 470. Wait. I think not yet. I think we need to do R40 first. Well, that's 28. Let's look for one more. Oh, they're all right here. 8, 7, 6. 7 is a 180. Right here. 6 is 300. This one should be 300. I'm pretty sure I'm done with 470. Let me see if I can spot a 40 real quick. Get a 40. Yeah, we got 40. So this one is the 300. 300 being R6. And R8 was 120, which was one of the last trios. Is that it? Is that all of them? I don't see any other resistors. I think that's all the resistors. I think that might be it. If that's it, that's probably the hardest part. Because everything else should be easier. Yep, I don't see any missing ones. Just got done doing 6. Got done doing 8 and 7. And the 40 one is the one I forgot to mark off. That's all of them. Resistors done. All right, the chokes should be really easy. They're all here. These are inductors, and they help clean up the current. So it doesn't like changing current. So it builds up a magnetic field. If the voltage or current drops, then the magnetic field will collapse, induce another voltage, and provide the greater current. I think L1, yeah, they're marked up pretty good. So what the inductor looks like on the PCB, it'll be just like a resistor. Well, I mean, on here it doesn't, I should say in a schematic how it should look. Let me bring up the schematic over here. So in the schematic, you have resistors, and so resistors, they look like this. They're just, how do you explain, like mountains. Inductors, let me find one. They're similar, but they're different. They look like hills. And so instead of trying to find it on the schematic, I'll just show it on the actual PCB where they're marked. So right here, you can see they're hills, like a butt. So you got the inductors there. And they're labeled as L. Not sure why. Don't know what the L would stand for in the denotating, but they're measured in microhenries. And so microhenries is inductance. Where's the last one? Right here. Where's the last but? Let's see. Yep, I'm blind. Let's see. Right here. This one says L4. I'm guessing L2 is probably a bigger one. Yeah, L2 is the power inductor here. So let's might as well get all the inductors done. We can mark these chokes off. We'll get that power inductor here marked off. Here it is. I think this one's the only one. Yeah, I'm not seeing any other one. Checking it says, I don't know what that says. It looks like Celsius, degrees Celsius. Yeah, I'm not too sure how these are marked. It's for sure the inductor. And I'm pretty sure this one's not gonna have a but. It might be marked as something else. And just have L. For sure a circle somewhere. It's looking at the picture, it's right next to a transistor. Right here, up here. And inductors, they have no polarity, since they give the same values. It's just a wire wrapped around the ferrous material. There you go. All right, what's next? I guess the diodes. If I can find them. Got one diode here. These is the only components. Just one type. Here's the other one. Make sure they're the same. Markings. All right. 4007. Oh, this one. Oh, this one's different. All right, this one's 4007, diode number 2. Diodes are marked. Oh, it's got the way the anodes goes. That's pretty neat. This one's kind of hard because the spacing is different. It's a lot wider. There we go. All right, and for the other one, yeah, good thing I checked. I thought they would be the same, but they're different. This one is diode number 1. Oh, and I messed up. So diode number 2 goes here. I rip this out. Put it over here. Make sure that the cathode goes over here. Cathode goes to the ground. And the anode from the power. There you go. And this one over here. Sweet. Those are all the diodes. Not all of them, since there's LEDs. Technically, these are done. Mark those off. Got the crystal. Already found where the crystal goes. Crystal also has no polarity. Yo, what's up, Pig Steel? Yeah, I plan on doing more streams just to give me more like of a schedule, so I'll be able to do more stuff, learn more stuff, all the kinds of stuff, and also treat these streams as like I guess like tutoring. I guess if you have any questions, just let me know. I'll stop what I'm doing to answer it and explain it. That's how the future ones are going to be too. I needed an oscilloscope for a project that I want to do with some LEDs. I want to actually see the data go through. I think that'd be sick. But other than that, there's going to be different ways the streams are going to be going. Some of them are going to be probably just chill ones. I'll just probably like be playing some games and wait for like people if they have any questions, and then explain those questions. Other ones are probably going to be more like sitting down like this, just have some stuff here. Other streams are going to probably be like designing projects, and I'll have that included. I want to get a camera for outside, like a nice camera for outside, but not too nice where if something happens, I'd be bummed out about it. Something that would be okay to have a casualty in, you know. Because originally I wanted to buy a really like expensive camera, but I'm not a photographer, so there was no point in getting that. But yeah, that's what I plan to do. This right here, these are pretty cool. These are capacitor trimmers. I didn't even know these were a thing. You set the capacitance like a potentiometer, and so the capacitance is different based on how you set it. I didn't know that was a thing, so it's pretty neat. Got both of these two here. Let's see. Oh, also here's the current project that I'm working on. It's a door, and so it's supposed to swing open, it has the gears on the inside, but it's not optimized. And also, you can see the door's like all wobbly, and so I just need to make it better. There's that. USB socket. I don't need the USB socket because I'm gonna be powering it through 9 volts. I guess they gave it's a micro USB right there. Let's see what else. Got the buttons, the header. Thing next up. Tactile switches will probably just fall out if I put them. Maybe not. You just pop in. There's one. Yeah, I'll just do the switches. These are easy enough. These switches actually have a certain way to put them. So you can see on the bottom, there's thicker plastic that connect the two sides. And so if I remember right, I think they're set up so this is one side of the button and then this is the other side of the button. And so when you're new to Arduino, you usually set this wrong so that it's actually on the same line. And so for me personally, I set it up wrong. And I've seen on like just on Reddit, like people that need help, they set it up wrong too. Good thing for on this PCB, there's only one way that it'll fit on there, so I don't have to think about it too much. But let me find another one. I can show the not the polarity, the continuity. I'm pretty sure it's based on. It's based on where the plastic is thicker. That's where the contact pads are. But moving this over here. This is a continuity test. This stand up. And so if there's continuity, then it'll measure resistance almost down to 0. So right here you see there's no continuity. Press down on the button, then it connects. But if you connect these two leads that are on the same side, you can see without pressing the button, there's continuity. So yeah, it's definitely something to look out for if you start with any electronics and buttons. You gotta make sure that you put the button on correct, or else you'll just have a full-on short and the button will be useless until you flip it the right way. Let's get this last button. I think this is the last button. How many are there? Tactile switches, 1, 2, 3, 4, 5. So there's one more. Where is this go? Looking for a square. Not here. Yeah, I can't find it. 3. Unless it's on the actual face. Oh, the reset down here. Every computer has a reset switch, and basically what it does is just connect one of the pins of the I guess microcontroller or CPU, and it connects it down to ground. And so when it detects that, then it resets everything. Let's see. Oh man, there's so much stuff on here. Look at the back. Oh god. I have to solder all that. My goodness, it's gonna be a lot. All right. There's also the switches. Let me cross off all of this. USB socket. I don't think I'm gonna be putting the USB socket because there's really no point. I always have 9-volt batteries. I say that now, but I guess capacitors. This is gonna be a long little thing. Also, I don't have the capacitors all organized, so it's gonna be just like the resistors. Luckily, they're just marked on, so it shouldn't be too tough. Looks like the majority of them are 0.1 microfarads, and microfarads being the capacitance of each little capacitor. This one says 104. Yeah, I don't know what that means. 104. Basically, I'm just gonna look at how many 104s I have. 104 micro is 0.000006, so that would make sense. So all these 104s are definitely the 0.1 microfarads, and the rest will be easier to figure out. One says 121. Is that the 120p farad? I don't even know what P means. What is P? I don't think I have a multimeter that measures capacitance. Let's see. Yeah, this one does not measure capacitance. So I'm gonna have to look up what the numbers mean. The numbers. Well, as he's telling me straight up. Let's look at the schematic. We got these are electrolytic because they have the they don't have two straight lines. It has one concave line, one dip line. The dip line means that there's a polarity for that capacitor, making it electrolytic. Ceramic capacitors don't have a polarity. Let's see. Oh, they're all up here. And they don't tell you the markings. They just tell you the values. So I'll have to look these up on my laptop. Let's see. I'll just start organizing these while I get that. You can get the LED. Where's the LED go? I remember seeing it. Right here. Diode number 3. Which one is the square for ground? There's a resistor, and looks like it goes down to ground. We know it goes 3 volts. It says positive. I'm guessing it goes this way. Hopefully. And there's that. So yeah, it says solder positive pole to the square pad. So we got that all good. Don't need the micro USB. Do the headers last. Switches last, just because they'll be hard to stay on if I flip it over. The electrolytic capacitors will be easy since those are marked. And where to start? capacitor 1, capacitor, those are all. What are electrolytic capacitors? Oh, they're up here. Oh, so it's 19, 20. There's 6 of these. Oh, and they're all the same rating. So that's really easy. Positive is the longer lead. Negative is with the stripe here, the ground. And so it's telling me positive poles are the 2 square pads. So that makes it a lot easier. And they're also marked with a circle, making it also a lot easier. So yeah, these are going to be blast. A blast. Because if you reverse the polarity, they'll blow up on you. So you gotta be really careful with electrolytic capacitors. Get all these done. This one's pretty easy, you know. Wish the resistors were this easy. All right, let's see. There's one. When these leak, they're disgusting. They're like, I don't know how to describe it. It's like when you're done eating like fried chicken, just all bad. And there's also a smell, like an acid smell. So you gotta be, again, really careful. Do not recommend electrolytic capacitors, but if you have to use them, you gotta be safe. Let's see, we got one more. 2, 3, 4. We should have 6. Oh, I just can't count. All right, there's 5 here. Where's the last 6? Looking for a circle up here. All right, sweet. All right, that was all cool. Look at this connector. This is a pretty dope connector. The back, I think it goes here. Maybe. Sticks on pretty cool. All right. Let's put the transistors. These transistors, they're like switches. And so depending on, for these specifically, which are transistors and not MOSFETs, they use current to activate them. Depending on how much current there is, will determine how much current it will let pass through. So orientation is just like here where the bump goes out. But kind of tough. There we go. Got 2, 3. That one's all in. For the transistors, if I remember correctly, it is not drain source base. Wait, it has a base. That's where the input current goes. Oh, these are different. Oh man, hold on, I need to read these. 79L05. That one is U4. U4. It would be the wrong one. Dang. Right. Let me rip this out. What a bummer. So this one's going to be the other one. Oh, and there's also regulators that have the same look. So that one says 05. This one is the 04. Wait, did that one say 04? Confusing myself. This one is for sure one of the transistors though. It says 79L05. 79L05. That's a regulator. All right. Well, it definitely goes here. Regulators are just they're made up of multiple transistors, and so it regulates the voltage through those resistors, through those transistors. The way they're denoted as regulators is usually telling how much the output voltage is for the last few numbers. And so since this one is 79L05, that means that 5 volts is the output voltage. The first set is just the type of regulator. It is the 79L or 78L. If I'm not wrong, I think 79 is negative 5 volts and a 78 is positive 5 volts. So yeah, I actually have let me show my collection. I got a couple of regulators here. So here's my regulators. Let me see if I have what were they called? 79L. I have a 78L. Oh, I don't have them marked though. So this one is the 78 series are for sure positive. 79 series are definitely the negative volts. And so I remember I had a bunch of 79. I have a 7905, I think. Yeah, this one's a 7905. Yeah, it's too hard to see, I think. But 70, oh, it was up here. The 7905 is a negative 5 volt regulator. And so you put in negative voltage and it regulates it down to negative 5 volts. And what the negative 5 volts means is just the polarity. It's just like if you connect the battery backwards, then you're inputting negative like 9 volts. That's all the negative 9 volts means. And the positive obviously is just the positive configuration. The reason why the oscilloscope needs a negative voltage supply is because in order to get a sine wave of the alternating current, the sine wave goes in positive and it actually drops down below 0 down to the negative voltage. And so alternating current has that voltage, what is it called? Just like a voltage difference of having both positive values and also negative values, switching up the polarities constantly. Unlike DC, which is consistently positive voltage. And so over here, I don't know what this says. I don't know if you guys can read it. 59014. That is Q2. Q2. Right here. In the enemy team, QQ. This one is a transistor. So this one's being used most likely as a switch. So then the leads. Seeing it in an actual PCB makes it a lot more. I feel like it's a lot easier to look at the PCB than to look at the actual schematics. And I'm not really sure why. Probably just because it feels like kind of bland looking at it through the paper, and it kind of makes more sense like physically looking at it and physically putting in each component. I don't know, it's kind of weird. Here we have positive 9 volts. That one goes up here somewhere. Don't know how. Like that. Like that. There we go. That's just gonna fall off the. Oh, here's another transistor or regulator. We got 78L. 05. I really lagged on that one. All right. So this one is a regulator and goes over here. I'm not sure how many components you would have to like mess up in order for it to like just completely destroy the microchip. It would kind of suck if if it doesn't end up actually working, but I mean, hopefully it does. I'm not rushing through anything, hopefully. And I tested all the resistors. There might be a couple where they might not have been done through the digital multimeter, but we'll find out. We'll find out. One last transistor or regulator. This one should be the transistor, the Q2. Oh, Q1. So we'll just get that right in there. Easy enough. All those are done. Yeah, so far, this is pretty tough. I would say this is a pretty tough soldering kit. Just because you have to manually measure each of these resistors. There is a way to figure it out through the bands, but that takes a little bit of time to do also. It would have been easier to just have them all marked out like ahead of time if they were just on paper and you're able to take them off the paper, put them in one by one. But not too big of a problem if you have a digital multimeter. Let's see. All right. Never got my laptop. Oh, it's up and running, but let's see. Just capacitor. We know the 104 is the 1 microfarad. 22, I know that one. Oh, it is just marked. So 22 p farad. So does that mean the 121 is just the 120 p farad? 321 Is that the 330? Oh, it says 331. Oh, okay. Okay. That makes sense. So 4, what would it be? 104. Oh, okay. So it's 10, and then 4 is indicating where you have to move the decimal point. So you move 10. That wouldn't be 6. A micro is how much would that be? 1,000, 100,000, 100,000th. So we have 10, then 1, 2, 3, 4. Yeah, that's kind of confusing. Let me grab a different one. Hopefully it's easier. This one just has 1 PF. P being penta? That's not right. I really don't know what P stands for. What is the P? 22P. This one is 3. All right, so yeah, they're just all marked. Yeah, if I knew what the P might be penta. 10 penta, that would just be 1 micro. All right. Other than that, 121. Oh man, I think it dropped. Let me check where I'm at. All right, I got 32% battery life. That's not bad. We got 22, 121. So this should be easy. I don't have to look up anything. Let's find out where the 22. It should be right here for the crystal. The 22s are really common for when using crystal here. And crystals are used as a clock for the microcontroller. And so basically every time it pings the crystal, it'll constantly update the microcontroller. And so even for the Arduino, the Unos, and whenever you're switching from the Uno 3 and going through an actual like PCB, you always have to include the crystal if you're using the Atmega 328. Just like over here. Wait. I have where is it? I'm not sure where I have one. I know, is it here? Nope, not in there. Yeah, I don't know where I have one. Oh, this fell off. Just set that aside. Now those two, we have, and there's a lot of just small little TX1 being header, I think. Nope, doesn't look. Don't know what those are. There's this. There's J6, which is a header. All right, let's get all these capacitors. Let's see, there's some more smaller ones. 331. That one is C2. Trying to find C2. Might be too tough. Yeah, I'll just have to go one by one, going from the left to the right. C1 is a 1 microfarad, 0.1 microfarad. There we go. Next up is C5, which is a 1 pentafarad. Is it penta? Penta would mean multiplication of 5, wouldn't it? P. Got P on my mind. Disgusting. C5. Still looking for just one. There it is. This one just, nope, that's 3. And this one? This one is just 1. So C5 goes in. Again, doesn't matter which way you put these. I'm just making sure that the number faces over here this way, just so it's easier to double check stuff. We got a G7. Do I have a 3? Do I have a 3? C9. What's C9? C9 is a 0.1 microfarad. Or was that C9? Oh, I lost it. Right there. C18. C18 is the same thing. There we go. Oh man, look, check the back. Oh my god. Look at all those. Look at all those chickens. All right, let's see what else we got. C10. Let's C10. Same thing. C11 is the same thing. So there's C11. That one's kind of tough to put in. All right, there you go. Bend that back. What else we got? Check it. These are the trimmers. And we got one hidden here, C8. That one is different. That's 120. Where's a 120? That's 331. These look like they're all, 120. Not bad. And I lost it. Looks like it's this one. C16 is 0.1. Starting to see a lot of them now. C15, same as 0.1. Let's see, I don't see any other ones. We got C20. That one is 0.1. And I'm not seeing the next one. We got C17, same, 0.1. Try and find another one. Oh man, I was on a roll. Too bad. C3. That's a 3. What was that small 3? Right there. Right here. That's C2. C3 is right here. C2 is 330. Which one is 300? That's 120. This one, 330. C2 is done. We got, oh man, there's some hidden ones. We got C23. That one is a 0.1. Wait, oh, I almost put the wrong one. C23.1. This one's like in between everything. All right, sweet. Try and find another one. I can't find. C14. Hold on. C14. 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 We got C14. We got C14. C who? C14. You know what time it is. You know what time it do be being. Shout out to the homie C14. Oh, forgot where the button is. Where's the button? Oh man. Should be over here. What? Oh, I see them now. Come on, come on. Do I not have a... Wait a minute. Did I, Does it not have... Hold on. I might have... Might have a different SD card in here. It looks like I do. What? What? This cannot be. What a rip. What a rip. I think it's the SD. Wait, that's hot as heck. Did I burn this out? 5 volts? What? I think that's a rip to the jukebox. Hold on, let me check this SD card. Seeming like a rip. Not like this. Not like this. I'm gonna double check this SD card. Oh, that is hot. That SD card is hot. I may have a... Broken the jukebox. Jukebox may be RIP. I'm gonna check this SD card though for the homie C14. Oh yeah, everything's here. Yep, everything works. Alright, this one goes out to C14. I think heck yeah. I definitely burn out the MP3 module. Hope kind of forces me to redo this. I don't remember how many. Oh, it's definitely gone. Right now it's like 300 milliamps. I remember probably being like 30 milliamps or something like that. So might have like just shorted out somewhere. I know it touched these, but that wouldn't have done it. If I reverse the polarity, the light wouldn't be on still. Alright. That's a big rip. I do have let's see. Where are they? I have one here. Thought I had another one. Oh, I do have another one. Alright. Let me check how much it should be drawing. Maybe I shouldn't, because I don't remember the pinout. I'll just call that a rip. RIP jukebox. Definitely hot. And not sure what happened. Definitely an error on my part though. Actually, let me crack it open real quick. Do a little intermission, you know? Quick slice and dice. Dang, I really got this. Why? Oh, why the resin? Alright. Maybe the resin wasn't a great idea. This was before the modular design though, so I do have to still revisit it just so it works with the whole system. Alright, I think this is just a rip. Yep, there we go. Oh man. Alright, let's get this. See what happened. I'm guessing I reversed the polarity, and I might have done that like a different day with the battery pack and not realized it. Because everything does feel hot. So usually if something feels hot, then it's because the polarity was messed up. Okay, checking straight up, all the connections are the same. So nothing moved. This though still feels really hot. All right. So yeah, I definitely reversed the polarity sometime and just fried it. So I'll redo that another time. Let's continue with this. Got a couple more capacitors. Check it out. Not really seeing any other ones. Weren't we on C14? Oh, C14 here. I was about to say, wait a minute. Wait a minute. C14 was 0.1. Got that in my hand. That was the whole point of the intermission. Come on. Got that good. And I think we have one last one. I think this is my last one. 121. That one's 120 p ferrets. And it will go somewhere. Find C. Do you see? Do you see? Do you see seaweed? Gotta be somewhere. I glossed over it. I have lost it. Trying to find a C7 or C8. C7, C7, C8. C8's right here, so we'll need a C7. There's C17. We got Imagine not being able to find it. Cringe. Yeah, it's a big rip. Maybe I should consult the manual. C7, C7. There's C9, C8. Let me try and find it. C7, C7. Maybe we just don't use C7. No. We have approximately 10 plus capacitors. Why do we need this extra one? That's what I'm saying. I say I just move on and then just naturally fall upon C7. So I'll just put that there. But that also is my last through hole component that bends the tabs. All these other ones are just plop and solder. All right, I'll spend the extra time looking for it. Let's see. We do have the other variable capacitors we can put in it. Looks like just like here. And this one right here. So there's those two looking good. What's up, T-Bone? I'm looking for C7. Where is C7? This is a oscilloscope build, so I can see data. So that'd be pretty cool. There's just one capacitor that I just can't find, and it's C7. So just gonna spend some extra time. I'll just go up and down until I see it. C7, there it is. Thank you, T-Bone. This was all you. I wouldn't have seen 7 if it weren't for you. There you go. All right. That was the last one. Now if I flip it over, there's only 2 things that fall out. Other than that, oh man. Came at a good time. Look at this. Look at the back. Oh my goodness. Oh man. Oh, of course, of course. For anyone who watches this and doesn't know, I actually ask for all my ideas through T-Bone. And yep. For this specifically too, wouldn't have been possible without T-Bone. He said, hey, you know, I made this kit, and if you want to make it, go ahead and yeah, there you go. And that's T-Bone for you. Let's see what else we got. We got, I don't know how I'm gonna do this because I feel like everything's just gonna fall. So I think for everything else, probably just one by one. But it's solder time. It's solder time. Do solder time. Do solder time. Let's get soldering. All right, so you know, there's the soldering iron. I got this solder that I use, and it's pretty good. 60-40. I haven't really tried anything else other than this, and it has flux in it. So I have other flux. I really don't think this flux is meant for soldering though, like soldering PCBs, but it works really good. Do I recommend using that? I'm not too sure because I don't know how safe it is to use. It says lead free and non-acid, so that's pretty cool. But I also feel like it's used for pipes because it says flush the inside of the pipe and wipe joint with a wet cloth. It works all right though. When using this solder though, I don't really need to use that solder. Flux. All right. So here we go. I guess just start. Let's start from this corner here. Nice and hot. I should probably clean. Yeah. I also have this stuff that helps. Stuff is called tip tinner, and so you just dip it in this tip tinner and it will tip. I mean, it will tin your tip. So what that means is it makes it all nice and shiny so that the solder doesn't stick onto the tip, and rather it sticks onto the actual component. After using that though, I'll use this wick, and the wick just sucks in all the excess solder or tinner and makes it ready to use. But yeah, so the tips are made out of copper, and so over time they actually wear out through the use of the solder. And so this one, I don't know if it's easy to see, but it's got some like divots in it. And so like the solder is kind of like acidic to it in the sense that it'll wear it away. And so when you tin the tip, it just allows it to be protected and won't wear out. Let's get soldering. You know what this is? We're in soldering town. Hell yeah. Alright, there's so many. We have one line done, I think. This one has a little bit too much. And the leads also like overlap each other, so it's a little difficult. The skulk sensor, I'm not too sure. Hold up. Bring that up again. Yeah, for the skulk sensor, might be a while. I know how to do it. It's just making the skulk sensor design, and I guess how I'm gonna do it is the real thing. Because for the redstone, that is, just because I'm a little uneasy on using these addressable LEDs, because I don't know if I'm able to read the output yet with the microcontroller. I should be able to, but it also might be a little bit complicated just because using these addressable LEDs won't be as universal as using the voltage drop with the Schottky diodes. The Schottky diode is like really simple and honestly is probably the best way to replicate the redstone dust, just because it allows you to like accept inputs from other places and the outputs and all that. So because I'm a little hesitant about the addressable LEDs, I'm gonna hold off. But basically the way it works is, let me find I have it. There it is. It's using one of these modules. And so the module, it's called I think just microphone module for Arduino. The way this works is that it's a is it called electrolytic? Electro It's like electro set, I forget what exactly it's called, but basically like electro. It has some capacitors and the resistors, as well as a amplifier here. And so you're able to adjust the gain, but I didn't really see a difference when doing that. And so what it does is that it will basically stay at half the input voltage. So if I put like 5 volts, it'll have the middle point of the microphone at 2.5 volts. And so if you talk, then it'll give you the waveform of your voice, since it's basically just like a thin plate and it's bouncing around. And the output will be the actual sound wave of your voice. And based on that, you're able to see like if it hits 3 volts, if it hits 5 volts, and stuff like that, for how loud something is. And through that, I'm able to like say, oh, send out this voltage, or send out that voltage, or send out this brightness, that brightness. And one thing specifically with the problem that I'm having is when you're sending a pulse width modulation signal through the array of LEDs that I had for the Schottky diode, redstone dust, I was having all the LEDs light up, even though I was telling it to send out a voltage of something like 1 volt. And the reason why it's able to go through all the LEDs is because it's constantly supplying 5 volts, but it's doing it pulse width modulating. So it's just cutting on and off the 5 volts rapidly. So that means that it's able to bypass, or not bypass, but it's able to go through all the Schottky diodes without actually dropping the voltage down to how I would expect it. So theoretically, the best solution is to use the addressable LEDs, but using the addressable LEDs will make it less easy to accept another signal. So basically, it would only be one signal coming from the skulk sensor. But yeah, a little rough. Other than that, though, it should be pretty easy to do. So hopefully I'm able to read the addressable LEDs, but if not, it's not a big problem. That. Yeah, one more right there. Move this over. All right. I'm gonna have to start cutting these. All right, let's see. Is that the top all done? No. All right, now time to get these out of the way. Gotta get your safety squints out. Oops. And a couple more. All right, sweet. Move that out of the way. These, I feel like it's better just to randomly do it. Actually, it might be bad. Yeah, the switches. All right. All these. At this here. Some of these leads are really close, so it feels like I'm going to be soldering them where they shouldn't be. Going to be a problem mostly in this area of just straight on wires. All right. Let me check over here. Running a little low at 20%. I'm gonna probably try to disconnect the microphone and then plug in a battery pack so I can charge, then also keep the stream going. Hopefully I'm able to get this done pretty soon. Alright, let me check. This soldering's pretty bad here. Wait, what? Maybe not. Alright, let me clean this up a little bit. Got here. Lots of leads. This one's pretty bad here. Dang, look at this soldering right here. That's a bad soldering one. There you go. And a couple more. That one flew high. Get your safety squits. Alright. There's that. Ooh, something I forgot to do is make a... Well, I guess I needed to make this first. But I need to make like a housing for everything. I'll probably do that tomorrow. Dang, this is insane. It's like a nest of wires. This is a pretty bad soldering over here too. There you go. Not too bad. Got one more here. One here. Oh, there's two here. Dang, I went sicko on this. What else? Looks like that's it. Oh, a couple over here. How did I... Huh. That's pretty bad. Let me solder this before I forget. Shut up and eat rats. What was that? Very nice, very nice. I have no rats at the moment. Unfortunate. Rats are pretty good. Depends on what kind of rats. Don't want any black plague, bubonic plague rats. Thanks, Mongoose. Mongoose. Appreciate it. All right. And chop these. Oh my goodness. Like, it doesn't get any thinner. It just, I'm like doing all the easy parts all around and then just slowly getting into the thick of it. My goodness. It's gonna be insane. By the way, Among Us, if you have any questions, always feel free to ask. I'll probably be streaming Wednesdays and Fridays, and I don't know exactly what. Probably be random, but the main thing will be if there's any questions. It'll be like tutoring, and so I'll stop what I'm doing and help you out. That's how I plan on doing the streams. Giving birth? What? What? I've never heard that one before. I made a real life cow giving birth. I've already put Minecraft sheep through too much. You have trouble helping. Yeah, that's why I don't see myself ever being like a big YouTuber or YouTuber in that reason. But for the people who are like subscribed and the people who are following right now, I like to help out, and helping them out also helps me out because I also want to be a teacher. So pretty good. Yo, viral. Do you see this? Let me show you this. Wait, hold on. What was that? Now draw her giving birth. Yeah. They say now draw her giving birth. Some people just remember me. Me beat PewDiePie. Of course, Among Us. I'll remember. Look at this though. Going viral with this. Look at this. Look at this door. I can't get a proper door. You really think this is gonna go viral? Look. Swings open, swing close. But it can't even stay. Best door. Thank you. Thank you, Holberger. How do you pronounce your name? It's not Howlberger, right? Hoolberger? Howlberger. Home security? Ah, yes. If you get broken into, it's definitely not my fault. I'll blame it on you. Holberger. Oh, nice. I'll blame it. I'll just say it was you. You forgot to lock the door, even though the door did this. And I'll draw you giving birth. You die. I miss the hamburger memes. Hamburger. Redstone computer. I don't know if I'd be able to do the redstone computer. It'd take a lot of blocks. Robbed your house? What? You'll blame it on the dog? I don't know, man. I don't know if I can back you up on that insurance fraud. Big Mac. Whopper. Yo, there's so many holes, man. By the way, what's up, Mr. Loot Llama? The OG. The homie. I like how you just came in straight up saying, no, draw her giving birth. Respect. Respect the deep cuts. For the flying machine, it won't be, I mean, obviously it won't be flying, but it will be the actual, like, block layout, I guess. And it will actually work where the piston will extend and the other piston will retract those set of blocks. And it'll basically be, what can I compare it to? Obviously it'd be like a robot. But it would be, I was thinking about it the other day, what exactly it would be like, but I just can't remember. But I mean, yeah, it's gonna be, it gets pushed out, and then that block will extend, and then bring that block with it, and then just keep doing that over and over again. With no purpose. They will have a purpose. They'll be moving on their own to a different position. Is their purpose, does their purpose fulfill anything? Probably not. With a vengeance. Light up Among Us? What do you mean by that? What do you mean by that? I think the way Among Us blew up, pretty crazy. And the fact of like the merchandise and I guess just in general. Oh hell yeah, Mr. Llama. A lamp. Grew up so fast. You raised me, Loot Llama. You raised that boy. Man, there's so many. Why are there so many? I feel like I've been filling up these holes for forever. Let me check my battery real quick. I'm at 16%. Probably gonna have to put the battery pack. I guess we'll do that right now. It's gonna sound a little different. Hopefully, yep, I'm already on power saving mode. How's it sound? Does it sound the same? Hold on one second. Ugh. Let me bring this back up. Let me see. Give you $1 if you build a life-size jet door. How about 50 cents? Can you guys still hear me? Hello, 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 hello? Yeah, okay, cool. Does it sound bad? Should I just quit? Quit now? Leave? Yes, leave? Sounds good, but leave? Hold on, let me read, I missed something. My YouTube slave has grown. Average YouTube user. Yes, yes, honey. Yes. Alright. Perhaps. Something weird I didn't know about is iFunny. I saw a clip, like a clip of mine. My friend told me, like he showed me, and it was for the jet doors. And the comments, all I saw was neat. So I guess that's a trend. I didn't know it was a trend. But yeah, the comments were just flooded with just neats. That's pretty neat. You guys still use iFunny? I never used iFunny. I feel like I missed out. Toxic. Yeah. Yeah. That's what my friend also says. He was a huge iFunny user back in the day. Well, I think he still has it. One of my other friends. Imagine having friends. TikTok is worse. Black. Yeah, that's what I heard. It's really racial over there. TikTok is worse? I don't have a TikTok either, but like not even a personal TikTok. But you think it's worse? Toxic, yeah. Oh man, iFunny used to be the thing though back in the day. I remember everyone would have iFunny. I didn't actually get a true smartphone with 3G at the time, I guess, with internet on it till I was like in my senior year. TikTok has some good ones though. It's got some hitters, some funny stuff. Oh, I almost soldered the wrong thing. Boy, I didn't do that for other things. No, but I didn't get like into social media probably until my senior year. I used to have Facebook, which was like my only social media. I would go ham on Farmville, but man, did it die out. No effort. That is true. Crop, you can't tell. Yeah, it's not a good social media iFunny. Sad, very sad. Also, it had there were like ads almost every other comment. It was crazy. I was like, what is this? What's happening? But for TikTok, I do have to defend TikTok. Even though, because I'm saying this because I don't even have TikTok. And when I do see some stuff from TikTok, little jokes land. Self-promotion. I read one comment for the Jeb door, and it was on iFunny, and the girl was like, "My gosh, why would you post this on iFunny? I would understand if you posted it on Twitter or Instagram. Like I post my stupid projects." And I was just like, nice humble self-promotion there, but also throwing shade at me. I wasn't even I wasn't even the one who posted it. Some other person posted it. But oh well. Respects to her. Shout out to her family. Oh, I love that one. That one was great. So today is Star Wars Day. And you know, no, what does he say? So today's my birthday, and it's also Star Wars Day. And here I have my girlfriend. Please blink if everything is fine. You should give credit. At this point, I feel like with some stuff, I feel like for the people interested, they're able to find it pretty easy. Maybe not for some other things. Um, so as far as credit, I don't really care too much. Yeah, that video. See, I'm telling you, some of their stuff hits. Because where else would that have been possible? How what's the farthest one that you've watched from that one? Because I think I've seen um there was one where it went up to they had oh, man, I don't know how many reporters. I think they had like three reporters, different reporters, and they had an overshot a thermal overshot. That one went for good amount of time. In the helicopters, yeah. Oh man. Only on TikTok though. So mad props to that. The only other place I could see that happening, as far as like duet kind of stuff, is like, um, what's that website called? Tumblr. I didn't know about Tumblr. It's also my birthday. The way he says it too. That one's going in the history books. What's up? Vulcan? Is that right? Sorry if it's not right. If it's not right, then I apologize twice. Bo. There's a lot of ways to say C-O-N though. Volcone? Yes, it is a rat-eating device. Volcan. Volcan. Alright. I'm sorry. Many apologies. Volcan. An oscilloscope, it'll show you the voltage frequency the voltage at a frequency. So it's useful for alternating currents which have sine waves, and so that have different voltage values at a set frequency. But it can also read data, and so data is just a bunch of highs and lows, and so you can see a square wave of that stuff. So it'll be pretty cool, pretty neat. Are you bullying? Are you bullying Volcon? You're really bullying Volcon? Hold on, hold. What is this? I didn't see him crying. You good, Among Us? Being toxic? You being toxic? When IC does? Yeah, definitely be cool. Redstone trap that drops children. Okay. Alright, okay, whole burger. We can't go dark. We just had a whole talk about how iFunny is toxic wasteland. Cooked chicken farm. Oh my goodness. Alright. Are we making cursed? Are we making cursed contraptions? Is that what we're doing? Mumbo and oh man. Don't be sussy bakas. Not in my chat. One trap that should be pretty easy to do would be the creeper door trap, where you have a pressure plate and 4 doors. That'd be pretty easy to do. Make 3x3. For the 3x3, do you mean the full 3x3 door? Because the etho door would be pretty easy. I say pretty easy, but it's probably going to take me like a month. It's because it takes a lot of blocks. Yeah, the etho one should be pretty straight. Oh, you mean the full 3-ball? Which one? Which one is it? The etho one? Bigger 2x2. Yeah, I feel like that. It also has the extra blocks though on top, which would be pretty tough. The 3x3 would need a double extender. The full 3x3. After a vegan ad. Oh, respect. Break the laws of gravity. Yeah, there's no way to get that suspended block. Scope. Seismometer. I haven't heard of those. Sideways? A double extender sideways? Oh, wait. Oh, like a floor 3x3 door? Kill chicken. Realize. Cry. Let the chicken eat you? What? Is that... Are those the steps recommended by PETA? Three by three trapdoor sounds sick. Oh, that kind of seismometer. That's what they're called. I have a... What is it called? I have like a working... When I was prototyping for the I'm blanking, the skulk sensor, I got it to work using a microphone. So I might just use the microphone. The seismometer is pretty, they're like huge, they're gigantic. I know the piezo buzzers, I think they detect vibrations. A triple extender. My goodness. I like the microphone because then you could theoretically program it to like accept certain sounds. But I don't know all that too much about that. Delays it. One issue I was having with the microphone is that if I would do a delay, there would be a spike right after in the microphone. And then so after it got in the spike, it would also get in a loop. And yeah, it was doing a lot of weird stuff. I was able to get it to work, what is it, consistently, to where I was able to do different volume levels without it like messing up. It wouldn't clip. It would do some weird stuff. It would get in a loop, and it had to do with noise. After I put like a capacitor for the power, it went away, but sometimes it would still like be a problem. With human teeth caps. What are you on, Among Us? Attach. Too weak. Hold up. Hold up. I was saying you attach a stick. Oh, to a joint. 2 weak springs. That's a good idea. The vibrations. I don't know much about. I honestly I don't know anything about seismometers for the earthquakes and all that. All I know is big rod in the center of the earth and small little needle and beep beep beep. That's all I know. A volume fade. It smooths the end of the clip. I'm using. Where is it? Did I lose it? I'm using this little module for Arduino. It's supposed to be a really simple one. It's just I was having that like that weird like feedback loop or whatever, the noise loop. The end of the clip. Well, it has a capacitors already, because it's like the module itself. So, when I put in the power supply, it smoothed out the initial. Because what it does, it starts. What is it? All right, hold on. Let me think about this. So what it does, you have the input voltage, say it's 5 volts, then the output will be 2.5 volts, and then whenever you talk, then you actually see the waveform, and depending on that waveform, it'll go like up to like 5 volts and down to like 0 volts. If you're like yelling at it, and it'll do that. The issue I was having is if I were to do a delay, I think what would happen is the microcontroller would stop receiving for some reason, and then once it would start receiving again, it would like read a super high value and then actually start reading the values. So it's not a problem. I don't think it's a problem with the speaker. It was a problem with the microcontroller. Eclipse? No, what it would do is it would jump, and then it would get caught in the loop because of the code. So what it would do, it would jump up to the threshold where I have it set for the code to do another delay. It would do that delay, and when it should be like right here in the middle, it actually jumps up again for some reason. And then it does the delay again, and it gets caught in a loop where it just keeps doing that. And so when I put the capacitor on the power, then it fixed it. Like it wouldn't do that anymore. Yeah, that'd probably help. Have like if it starts up again, maybe continue the delay. But Yeah, I don't know why adding the capacitor to filter the voltage helped out. Again, I think it was just the code. I had the code messed up. But I want to do the other redstone dust before doing the skulk sensor, just because with the Schottky diodes, it's a little bit weird. But don't know. Still working on the door too. And I also have the etho door I want to do. Too much stuff. Too many things. I also have other stuff to do too. Like I have a whole truck to paint, but I haven't painted. For my dad. I have it like sanded. I think I'm almost done sanding. And I have to primer and paint. Then maybe I'll do a wet sand. Maybe I'll do a clear coat. I don't know. Whenever I paint anything, I always take like a lot of months thinking about it, and I finally do it and knock it out in like a couple days. Honestly, anything I do outside is always like that. Short pulse. So at first it, man, these are all over the place. So first it's on, and then when it extends, wait, hold on. Oh, so you mean like when it leaves the block behind in Java? I honestly don't like electromagnets. Just because they use so much power. But I mean that's kind of my fault. I got the wrong wire. Should have gotten the thinner wire. But with just magnets alone, I should still be able to get that effect. I mean, I was able to get that effect when I was just testing. It's just whether or not it's consistent. I'm not too sure because I didn't test it all too much. And honestly, I feel like it should be consistent. But yeah, just not sure. I should probably do that because it's been a while. I think it's been like 2 months since I was testing the sticky piston. Slime. I think anything bigger than 2x2 and the etho door would need like the flying block design with sticky pistons. I mean with sticky slime blocks. Yeah. That's an insane build though. That build would like it would need like a cavity here and then the actual door like all the way up here. Might as well make a whole computer at that point. Oh. Oh. Bend this. Slowly making progress. This is mad insane. By the way, thanks guys for hanging out. Appreciate it. Again, if you guys have any questions, just let me know. Like anything, any questions about anything. You can ask me if the world is flat. I'll tell you, of course it is. Why are you even asking that? Everyone knows it is. Oh man, there's so many. Oh, how could you? Holberger. You betrayed me. How could you? This one's kind of weird. There's a lot of points where I just soldered multiple ones. Do you guys hear these like bouncing all over the place? Like just shooting all over the room. Yeah, honestly, I don't know why people are still round earthers. I mean, no disrespect to them. I mean, let them live their life. Let them live their life wrong, I should say. But to each their own. If you're a round earther, you might as well be sleeping on a round bed. Users. I never soldered that one. You guys ever met a flat earther other than me? Obviously. Maybe they're onto something. Christopher Columbus did sail the ocean blue in 2002. And he was able to go to India. I'm sorry, guys. This is all false information. Please. I know I'm mainly a education channel. Please forgive me. We're supposed to drink water. I think that's what the government wants you to think. We don't need to drink water. Come on. Again, I'm sorry, guys. This is all false information. This is misinformation. Look how nice that looks. You know, a little bit more than 3 hours ago, this was all in a little bag. But now it's outside of that bag. So not bad. Why can't you throw it like a tennis ball? That's what I'm saying. That is what I'm saying. And we still wonder when the truth is already out there. People just don't want to see it. You do music in Redstone? What? What are you thinking? Yeah, that'd be cool. I don't know about sending stuff though. Because right now it seems really expensive. So because I'd like to do like be able to like just send stuff out to people, but don't know. Do not know. Went through the roof? I think. I know even before, it cost a lot to send stuff. But I'll be more than happy to send stuff. Not currently though. Especially with these designs. I mean, look at this one. It's dead. It died. It doesn't work no more. Why? Why? It's a big rip. I think I reversed the polarity. Compressed. Maybe it was decompressed and you just compressed it to its original position. Are you sure you didn't explode your computer? Did nothing really happen? So many. This is just straight up a rat's nest right here. Straight up eating rats in this rat nest. These soldering points aren't too bad. This is my my first time doing stuff like this. Hey, thanks for hanging out. Whole burger. Take it easy. So it's not too bad. These are pretty gross though. Like if I put my finger, it just grabs. Oh man. All right, let me get rid of some of these. That one's not soldered. This one is. I have no idea how many of these I've cut. Probably a lot. Probably like around maybe 2. Maybe 4. If I was really trying to guess, let's say 10. I'm scared that some of these aren't soldered and I'm just going to cut them without knowing. Or that I'm just missing one. This is getting really scary. Like these are popping off next to my eye. Recommend using side cutters for these. Not what I'm using. I'm using some shears. They're not meant for this. I overlapped way too many times. There's like so many wires soldered on one. This one's now bridging across to a different one. There you go. What else we got? These are all literally clumped up together. It's literally impossible. All right. You got my surgeon hand up in here. That one's good. What's up, Quizbee? We're out here soldering. What's up, Happy Side? Very especially to make little discs. Hold on. Are you still typing? I think this is my... So Volcon. Happy Side, are you still typing? I only see... But is it possible to make little discs that... Alright, cool. Just making sure. Because I am on my phone. So I don't know too much about how the chat works. Also, don't worry. Don't worry about thinking you sound stupid, because no way you can sound dumber than me. No dumb questions. But there can be dumb answers. Don't be shy. These streams are mostly for you guys. Ask any question. Also, little discs. I don't like RFID. I think it's witchcraft. I think RFID is why the world is going how it is going at the moment. No, I'm just kidding. The jukebox uses a MP3 module, and it just has a bunch of different files on it, and I just toggle straight through them. So it doesn't know if it's actually cat. I just have the cat file on there. Playing the jukebox, play a certain song. Yeah. The way I have it set up is just... Wait, hold on. So you mean, if I put the disc in, it'll automatically play? The way I have the current jukebox is just whatever file you put into it, it just plays that. Plays it back. But if you want it to actually play, as soon as you put the disc in, they already made that. Like, say, there's a lot of ways to do it. The way I did it is just an SD card. The way you suggest it could be like RFID if you wanted. It could also be like the disc has its own resistance. So like you put it in, a microcontroller reads what resistance it is. And then once it reads that resistance, then it will communicate with the MP3 module and then play that file, that specific file. So if I were to do just like how you said, putting the disc in, it would probably be doing it through the resistance, because that's how I would know how to do it. The smarter way probably would be RFID, just because it's like slick. You won't really see it. By the way, what's up, Erdison? Is it Erdison? I'm butchering your name. I'm so sorry. Thanks for all the continuous support, dude. I always see you. It's always nice to see people, same people around. Always cool. And right now I'm doing an oscilloscope. Here it is. Almost done, I would say. And yeah, it is what we're talking about. Happy Side was asking about the MP3 module and how it would be possible to just have the disc put in and then play the song that way instead of having to press a button. And so there's a lot of ways, but it's mostly like, just like with any of these projects, there's a lot of ways. It's just, what way do you want to do it, I guess. Like, what build is it that I've had multiple ways? I think I don't remember. I guess with like the button, I guess with the pressure plate, the way I have it is just you press on, unpress off. Another way would be you use a microcontroller to find out when you press down on it. You let go and it still does that delay, and then after that delay it turns off. And another way is you press it and it actually retracts the button or the pressure plate. It keeps holding it there, and then once the delay is over, it pops back up. So there's a bunch of different like ways to implement stuff. It's mostly just how you want to do it, I guess. Or if you already know a way, then to do it that way. But that's what's kind of fun about like replicating stuff, is you can do it your own way, and then it's not wrong because there's no real way of doing it. It's just real way of doing it. But yeah. Oh, come on. No problems. Thanks for hanging out. But I hope that makes sense. If that didn't make sense, then keep asking, I guess. Does that give you kind of an idea, Happy Side, of how to implement it? What is an oscilloscope? An oscilloscope is think about if you know what a multimeter does, or a voltmeter that reads a voltage, then it's like a multimeter, but on steroids, and it's super powerful. Because what it can do is, for AC, then it can actually show the frequency of the sine wave. If it's a square sine wave, I mean, not a square, if it's a square, what are they called? A square function or a pulse width modulation, then you can actually read that and see the on states and the off states. You can read data, and data is just on states and off states. And you can just read like how much voltage is going through. And so it's really helpful with troubleshooting, and should be pretty cool to see all the data stuff. But again, just think of it as a multimeter, but like on steroids, like just super powerful. And by the way, Happy Sai, that was a really good question. I'm probably gonna hook it up to some addressable LEDs or to the microcontroller once I'm done with it. And then hopefully we'll be able to see the actual data. I'm not too sure though, because I've never used an oscilloscope. So this will be my first time using one. So I won't even know if it works. Let me see on here. Right here, you have switches. And so you can see there's alternating current and direct current. You also have the range. So right here, you have 1 volt, 0.1 volts, and 10 millivolts. And you also have the sensitivity, which is ×5, ×2, and ×1. And you also have over here switches. And some of the switches, you can hold the data and you can continue watching the data and just through all that stuff. Again, I don't know, but I'll have to like do a lot of testing. Quibsy, thanks for hanging out. I'll try and stream Friday. That one will probably be on my computer, so I'll be able to do a lot more stuff. There's so many wires. So many wires. I need to make sure that they don't overlap where they get soldered, because then they're like impossible to cut. All right. Get these over here. Oh, man. I cannot cut this one. Get these. There's so many just straight wires everywhere. Just so many leads. And they all lead to nowhere. I'll have a lot of jumpers for when I do more circuits. It's insane. Oh, this one's gonna go far. Oh, never mind. It broke before it launched. This one. This one's like jammed in. There we go. For this, I need it because I want to see data from addressable LEDs. And what that is let me grab the paper. So any data is just basically so data comes in bits, and bits you can think of as zeros and ones. And zeros and ones you can think of on and off. So on being high, and then off being low. And so I don't remember too well. I believe every state is a bit. So this is 1 bit, this is 2 bit. We'll have 3. We'll have another on of 4. And then we'll do 1 off. And so we'll just call these bits right here. So there we have a total of 5 bits. And so any logic that reads this, or any code that reads this, will determine, oh, if I get this code, this specific code of on, off, on, off, then this means that you pressed the letter M on a keyboard. But if it was on, off, on, maybe it was a different letter. It would be L on the keyboard. So you'd be able to read the actual data using the oscilloscope, the actual signal being sent. But yeah, that's data just looks like this. Data is just a bunch of on and offs, a bunch of highs and lows. And since the oscilloscope reads voltage, then it's able to actually see those on and offs. So it's pretty neat. Hopefully I'm able to get it working so I can show it working. But other than that, it could just be used as a multimeter too, or a voltmeter, so you can see the voltage. And I do need a better voltmeter, because at the moment I use an analog one, and I have a very cheap digital one. What's up, Jamie? We are building an oscilloscope. There's so many leads. These live streams are going to be basically like tutoring. All right. So if you have any questions, just feel free to ask. Questions about anything. I hope that makes sense, though, of what an oscilloscope is. I know it's not the best explanation, because I don't really know too much about them. I basically just know that they read voltages. The addressable LEDs are pretty cool though, because each one has, well, each individual LED has a microchip, and so it receives data, and then from that line of data, it actually subtracts some of the signal, and then it continues that data through. It basically, I remember I watched a video, and the way it explained it is it grabs the data it needs and then deletes it and then sends the whole line through. And then it just continuously does that for each LED until it has basically no data. Then it would just not communicate to the other other LEDs. It's pretty sick. Pretty sick. Before getting the addressable LEDs, I was thinking about just putting a microcontroller for each LED, but that would be really expensive. Water-cooled oscilloscope? I mean, I don't know. I don't think you would need a water-cooled oscilloscope, honestly. Some things on Google. About the oscilloscope? Or about the data? Because there was a... Oh, it only had... That video only had like a little bit of views too on it. So it was a little tough to find. But data's super neat. Super cool. And it shouldn't be seen as complicated. I feel like it gets lost in the sauce. Shouldn't feel more complicated than what it is. Just basically on and offs. Just like with any electronics. For the low price of $18,000, get yourself a water-cooled oscilloscope. Also, Ben J. Rob. I almost called you Benji. So Ben. No, stop it. I am just a humble peasant, a pimmin. I am your YouTube slave, as as Amogus described it. What else we got? Almost done. I think I've only got 4 more leads cut. Look at this. This is only for the long wires, because I still have a couple more stuff to solder on, but I won't have to cut them anymore, I don't think. Hopefully I won't. Also, what time is it? 3:50. I think I started at like 2:30 around. So that means 4, 6? It's already 6. What? Alright. I also don't know how long streams will usually be. For sure, I'll try and start them at 2. And then maybe end at 5. I don't know. I really don't know. 2 hours. That's it. Yeah, 3 to 2 hours seems pretty pretty reasonable. But also some streams might just be like laid back and just waiting for people. Two-dimensional plot. One or more signals as a function of time. I don't know if this one's able to do more than one signal. I don't know how many probes I have. This is what it comes with. 2 alligator clips. So this is basically just one probe. I think this one is just one probe. It's not that powerful. But yeah, you can have different signals. You can read different signals, which is pretty cool. Not this one, maybe. But a full-size oscilloscope. You can read different signals. See how each one affects the other. And one thing I want to do is get a... They're called an op amp. And they're called operational amps. And they like just like a comparator or Minecraft comparator. It actually adds the voltages. It can subtract the voltages. It can derive the voltages with like calculus, and it can take the integral. It's insane. It's honestly insane. And I mean, I feel like I feel like ever since the whole like digital stuff with all the with I guess like Arduino and all that stuff, some smaller components like electronical components, ICs, kind of get like kicked away. No one really wants to learn them because basically the ICs, I don't know. The microcontrollers can do anything nowadays. I see the door. MC Chicken is good. Yeah, you see the door? It works 100%. I'm kidding. It's kind of sloppy. It's it needs a lot of work. Basically, this hole here, it needs to be there has to be a guide for it, or else it just wobbles. There's no support. And so I didn't think of that. But I mean, I got the gears to work. Let me open this up. Show the gears. So here's the main gear. There's a servo with the gear. And when I connected the servo to the microcontroller, it moved the gear pretty good. Right now, it's like too torquey and it needs a supporting arm here, so it won't actually turn the servo. But the servo does turn the gear, and the gear did turn the door, but the door just wobbles, so there's no support. I kind of don't know how to give it support. Because right here it's gonna be bumping up against the block, and I guess I can give a little bit of support here, but it won't be that much. With the gear in, it does give some support that way, but there's no support this way. So yeah, black on top. So 2 blocks, that would help. That would I mean, that would fix the stability issue to put the block up here too. And so it'd be like a through, have support. But I want to challenge myself to get it working like this alone. But It kind of worked, I guess, but it also kind of didn't work. I think I have like just 1 day invested in this, so I haven't worked too much on it. The gearing I haven't worked too much on, or have I have worked on the gearing a bit. The actual structural part of the door I haven't worked too much on. AC, a happy side. Thanks for stopping by. Did I get all these? See you, Jamie. I think that's it. I think now is just the bigger components, the switches and everything. The switches, oh, I guess, no, they don't matter how you put them. They do matter. Never mind. No? Oh, you're saying, okay. My bad, Jamie. You're saying bye to Happy Side. Very kind, very kind. Right. So these are 3-way switches. The way they work, they have how many contact? They have 1, 2, 3. Hold on. They have a total of 4 contact pads. There's 1 main pad, and depending on how this slides, we'll connect that 1 pad to the 3 other pads. And so right here it's connecting 2 here, 2 here, and finally 2 there. And over here are the pins. And so this one is actually a, hold up. Is this? So it has 8 pins total. 2, 4, 6, 8. Yep, that's 8. And so when it slides, I think actually, hold on, how many outputs does it have? It should only have, right here it's connected 1. This is weird. Hold on. I can test this. I honestly don't know what kind of switch this is. It just says slide switch. I think I'm missing one. There it is. All right, let me test this out. So this is just a continuity test. It just measures the resistance. If there's no resistance, then it will drop to almost 0. I want to see if these 2 leads are the same. No, they're not connected. Okay. Oh, sorry about that. That was a call. Okay. So these switches, it has a total of 8 contact pads. And so right here you can see 8 pads total, or 8 pins total. So there's a pad for this pin, a pad for that pin, and individual pads for these pins here. And so sliding it across, right here is connecting probably the top pin to the first top pin, first bottom pin to the first bottom pin. And so basically what it's doing it's like having two separate switches in one switch of this type. And so that means right here, it's probably sending power over to another one of these pins. And then while that's doing that, it's probably doing another thing over here where it's sending power over here. So yeah, just think of it as two switches in one. Pretty neat, pretty crazy. All right, they're both soldered up. Just subbed, what? How do you see this? That post. Oh, the reason they get a lot more than the actual YouTube is because they're quick, and so I feel like they're also shared more. Oh no, they're for sure on a like huge platform, so a lot more people see it. Because I mean, I know it gets a lot more attention, just from other people sharing it, and it's just really depending on like where it's set out. Like YouTube isn't a great place for exposure, and if I wanted exposure, I feel like I probably do probably TikToks would be the best for exposure, but these videos are just mostly like educational, so that's why, I guess that explains it. Yeah, I'm glad people see it too. And for the people who are interested in how it works, then these videos on YouTube are hopefully pretty good. Hopefully they explain everything. Oh, okay. Dropping in. Thanks for checking it out. Sup? Is that a good way of saying your name, or is it like soupy, or I feel like it's sup and then saying sup ikuruzu. That's how I feel, maybe. Let's see, there's so many pins. Thanks for stopping by, Edison. Have a good one. These switches are insane. A little tough. There's also these other parts in order to get structural integrity. They need to solder. I think I missed on this one. Everything is heating up also. All right. Check this out. Make sure definitely on. I missed one over here. Probably missed this one. Missed another one. Get this one all done. Focus it. Focus. All right, sweet. Dang. These switches are like gnarly just because of how close the pins are. All right. Get these. Oh, that's bad. All right, I need to get the wick for this. I accidentally put too much solder and it made 2 of the points connect. So in order to fix this, I'm using some wick, and it just sucks up that solder. So now everything's all good. There we go. Those are all up. Cool. All right. Now time for these. These are pretty sick. These are variable capacitors or capacitor trimmers. And you can change the capacitance by turning this capacitor. And so I never knew that was a thing until I got this kit. That's insane. Insane. I don't know how they work. I don't even know if they're... I think they're ceramic. Maybe. Oh! Alright. Okay. We're okay. We're okay. We just died a little bit. My phone fell. Oh, you got this back up. Alright, cool. Don't know what happened. I think it was the soldering that got in the way. Okay. Okay. I think I'm okay. That was crazy. Alright. Anyway. Yeah, trimmer. This one's tough. I don't know how to do this without potentially burning myself. So I might burn myself because I'm holding the capacitor while trying to solder it. Hopefully I don't burn myself. Alright, cool, I didn't burn myself. Now I just soldered one side and now I'm soldering the other side. There you go. Easy as that. And now I'm fixing the other side. There you go. No burns. Alright. Hopefully I don't burn myself again. Okay, good thing these are the same trimmer parts. If they were different, that would suck, because then I would have to unsolder them. But they're the same. Let me check this out. Oh man, there's like no good way. There you go. Ah! This is a mess. Alright, cool. There you go. There's that. You got another one here. Done. All right, cool. Let me make sure they don't connect. Almost done. Look at that. Oh man, that's looking pretty good, pretty complete. Now we have a bunch of headers. Header? I hardly know her. Right? This one is a 7-pin, number 7, female. Guessing this one goes here. J7. 1x2. Yep, that's the one. There's no way I burn myself with this one because there's so much plastic between it. Oh, it doesn't reach. No. Okay. So I have to hold this one while soldering it. It would have been a good idea to solder these first, but I just need to angle it somehow. There we go. What's up, Adrian? I hope it's Adrian, right? Is it? I don't know. We are soldering out here. Look how crooked that is. That's a crooked header. You can fix that just by melting these two slowly. Is that good? A little crooked. All right, we got some more. There's another female. Oh, this one's J8. There's a J9. J8 is right here. Alright, just like the last one. Easy peasy. Easy peasy, baby. There you go. Oh, that's perfectly straight. Look at that. I'm kidding. It's pretty terrible. Now let me straighten this out. Alright. The soldering iron's like sticking for some reason to some of these headers. That's pretty good. Let me get this pretty nasty one. This one is for power. I don't know how it would receive power. It's J9 though. It's I guess a different way of a different 9-volt supply. I'm not sure. This one's also tough to get. We'll get one side. The other side. Is that? Oh, that's actually perfect. Cool. And we got these male headers. This one is... What the heck? This one is only has... It says 1x3. That one's a 1x2. They'll have an extra header. It's kind of weird. 1x4 goes over here. Okay, this one for sure I'm able to burn myself. So I'm just gonna set it down. Luckily it hits the bottom, so I can easily solder them. Yeah, my soldering iron is starting to stick onto these pins. Not good. It's gonna end up eating away at the tip. Those headers were easy. That's pretty cool. These go right here. That one says, this one's for data, for the microcontroller. Kind of sick. I don't know how to use any of that, but let's get these headers on, I guess. And don't know how to do this without burning myself. What's up, Matt? Let me just we'll just lean this like that. Try not to burn ourselves. Ourselves. I should just say burn myself. Yeah, this pin looks like a casualty. It's a big rip. I don't even think I can desolder it. Hopefully it straightens out. Nope. Alright, let's get the wick. Just gonna desolder it. Try again. Did that do anything? No. Alright. How hot do these get? They definitely get hot. Hot enough for me to burn. Maybe this. No. We'll just do it all there. I'll save this header for last to fix it. Oh, is this for this? Maybe. I have this extra male header that I don't really know where it goes. Let's get the power. That one's easy enough to get soldered. I don't know if I should bend them. Nah, it's cool. Yeah, that all good. Oh yeah, it's soldered. That is for sure soldered on there. Alright, where's all these pins here? Oh, they're all right here. This one is J3. This is marked J3. That just like that. Okay, this one's gonna be insane. This one will be insane to solder. How many pins are here? 2 times 20, 40 whole pins. 40 times soldering this. Insane. Wonder how long it's gonna take. Alright, I got that side done. So now I'm gonna make sure this is all flat before soldering it. Okay, yeah, it's definitely moving. I need to hold it in place. There you go. You always solder one side and then solder the other. There you go. Alright, now I can go absolutely blicko. I can do this in 1 minute. Let's go. Starting 4/20/20. Let's go. And let's get it. Okay, it doesn't look like it's a good start. Okay, I feel like those two did not count. Alright, that one definitely counted. That one not so much. How are we on time? Ooh, 20 seconds in. Not looking too good. Not even halfway. Oh no. I feel like I'm putting too much solder on some. We're going. Where's the middle line? Where's the middle line? Ooh, and we're at 60. That means 40 seconds already. Does not look good. I do not think I can do it in a full minute. Slowing down here. Getting pretty hot. And oh, I still have 10 more seconds. 10 more seconds. Oh. Let's see. Let's see. Let's see. Let's see. Got stuck. I got stuck. No, that's time. I'm disappointed. All right, this one for sure didn't get soldered too good. This one I didn't get soldered. I missed it. What a rip. Let's see, how far did I get? This one looks like it barely got soldered. 1, 2. Wait, actually, that's one I missed. Accuracy wasn't too great. For the most part, though, looks like I got a majority of them. Now, 1, 2, 3. Maybe I missed 8. It's not too bad. How many is that? 32? 32 pins, give or take, in 1 minute. Not too bad of a speed run. This one that one's good. That one's good. They all seem pretty. That was not too bad, not gonna lie. I thought it would take like 10 minutes just to do. So now this goes here, and the display gets soldered onto that. Where is the display? Check this display out. 4K, 120 hertz, 144 hertz. I'm just kidding. I don't know what it is. I think it's just OLED. Oh, it's LCD, not even OLED. RIP. There's these pins here, which I have no idea about. Pretty sure it just goes like that, though. Those must be for some other thing. I think I'm almost done. Okay, for some reason, these don't clip in, though. Let's see, these pins go in. Go in. Go. Yeah, there you go. All right, sweet. Pretty sure they go like this. Oh, yes, it does tell you. Verify, yes. Very important to verify. Okay. That's about right. Check voltages. I did not check voltages. Oh, I need a short. Oh, gosh. Oh, geez. I'm getting ahead of myself. Oh, geez. I'm getting way ahead of myself. Ah, geez. Okay. Should have read the instructions. Who reads instructions nowadays? Come on. All right, let me solder these. I need to check voltages. How do you check voltages without an oscilloscope? Make sure these are flat. I need another male header. I don't know. There it is. There it is. Yeah, that all good. Nice and soldered. A little crooked. Okay, let me read this. I think, is that all the soldering? I still need to solder this. How do I solder this? The heck? Kind of weird. It's got like gold plating. Oh, that is not soldered on. I feel like those don't solder. Oh, I'll try anyway. Let's see. Definitely does not like it. Alright. Well. That's hot. That's hot. Yeah. Ah. That's hot. Ah. Alright. Let me cut this. Oh, man. That's scary. Alright. Not bad. Alright. Time for testing. Alright. Let me go through the list. I think everything's soldered. So I'm just going to turn off the soldering iron. Hopefully it starts cooling down. Oh, I'm not done soldering. I still need this. That's all right. BNC connector. Is that what this is? Yeah, that's what that is. I have these standoffs that I don't know where they go. Basically everything here is done though. With the exception of the USB socket. Got a test signal ring. Lead cut off. Okay. So it wants me to make a ring here. Oh, and I guess it's gonna show a square wave. So it says it's gonna show a square waveform of 1 kilohertz at 3 volts. And I'm guessing that's probably the clock. I just turned off the soldering iron. Come on. All right. And it says to short the JP3 solder. I have no idea where that is. JB3 over here. Oh, is it already shorted? Yeah, that's already shorted. And I guess all I have to do is do this test ring, which I don't really need to do anyway. But I'll do it. Man, I got myself good. I just touched the hot iron. Do not do that. Do not do as I do. Good thing I have calluses, or else I would have had no finger now. There you go. So there's that test ring. Feel like it's from the clock, maybe. All right, now for the panel. Oh, that's perfect. All right, let's get this done. I don't know. This should be fine. Just soldering straight like this. Oh well. Let me get those two. I'm just gonna solder 4, then pop the whole thing off. Minute. Is this? Oh, it's off. I was wondering why it wasn't melting as efficiently. I think I should be able to pop this off. Oh man. Ugh. Okay, that's not good. That's very bad. It just pulled out all the pins with it. Look at this. Oh no. Oh no. No. Alright. Here's an easy fix. I just put it back and act like nothing happened. Hopefully I'm able to do that. Oh man. Alright. There you go. Good as new. Now I put this back in. And never speak of it. There you go. Like it never happened. And now I'm not gonna pull it off. Alright. So let's just get these all soldered up pretty easy. Should only take 2 minutes. 2 minutes maximum. I'm about to go blicko. Alright, let's get this. Oh my goodness, there's so many. I feel like I'm gonna have no more solder after this. Uh-oh, I'm stuck. See how it's going so far. Oh, I missed the first, second set over here. Okay, well, those two. All right. All right, all right, all right. Almost done. Almost there. You're good. You're good. You're good. You're good. And is that it? This one kind of looks a little weird. That's all, I think. Oh yeah. I think that's it. I'm not even gonna try to pull it off. I don't want to pull any pins. Okay. So that's it. All right. So now it says to test it. Do I even test it? Should I just call it good? Just act like it's all done? Never look at it again? Oh, I never finished this header. I'll keep it like that. It's a nice little feature of that's like a maybe a 30-degree angle header. Let me check. See that? Yeah. Okay. The moment of truth. Alright. I have a 9-volt supply that I can use. Oh man. How do I even turn it on? Does it just automatically turn on? It says 0 volts. That's a ground. Okay, the ground needs to be changed. How do I do that? Oh my god. 0.5, 5, 0.5, 50. Oh my god. It's working. The ground is off. Like really off though. Hold. 0.5, 0.2, 0.1, 50. Oh, those are the seconds. Oh, that's adding, subtracting. 1 millisecond, 10 milliseconds, 50 milliseconds, 1 second, 2 second, 3 second, 5. Oh, well, this is cool. Auto. Normal. Sing. Sing for me. Okay. This is crazy. I have no idea what I'm doing. I don't know what that symbol does. Is this what I move? This is what I move. That is not what I move. I don't know what I'm moving. Is anything heating up? Is everything fine? I think it's fine. Oh, I moved these. The capacitors. Of course. How could I forget? Okay, let's move this. How do I select? Oh, okay, okay. This is this this on the right, the little blue arrow, that's showing me the voltage on the graph of 0. Okay, so you see right here, it's showing me a lot of stuff. There's some noise. So it's a pretty noisy oscilloscope, but it's also not on the right ground. And so you can see, even though it has 0 volts, it's showing up here. Oh, I can. So what does it want me to do? Check voltage. Should be around 3 volts. By 9 power. Oh, I never. All right. Here I got my voltmeter. I'm gonna check the voltage. Where's the ground? not 3.3 volts. What do I do? Yeah, it's not at 3.3 volts. Oh, I can check these other V1 is at 3. That's at 3.3 volts. Oh, is it because that's a... Okay, so I'm checking this up here, J2, when I should be looking at TP22. Everything's good. I'm gonna probe that maybe. Let me just... Okay, so these are the probes. It's got a fancy little connector. And so now I can put this here, ground this out, and running. Is this soldered on correctly? Should be. Ground there. Let me see. Okay, I messed with this. So let's reduce that 500 seconds. Maybe 50 milliseconds. It says 1000 hertz. Auto. Okay, connect that here. Oh, it's doing stuff. Not the stuff I want, though. Oops. What does it tell me to do? Trigger LED blinking twice indicates booting up is good. You should see. I think I may have done the LED wrong. Oh no, it does blink. Do you see signal from your finger? It says attach probes to J1. Oh, that's J2. That's J1. Finger. Don't see a signal. Maybe if I get... Okay, I have my power supply on. My alligator clips. Oh, because it's on ground. Bruh. That's okay. Okay, it works. It works. Look at this. Okay. Okay. I may have destroyed my life. Okay, like it wants to do it, but it's not doing it. Now you see it wants to, but it doesn't. Okay. For sure I need to fix the ground. So I'm going to switch it to the ground. Hopefully nothing... Oh, look at that. Okay, hopefully nothing messed up. Do I move these trimmer pots? Should I? I feel like I should. Okay. Let me try moving the capacitor pots. Trim pots. Trim capacitors. I don't know how to move these trim pots. I think I'm moving it. Okay, that one's not doing anything. That one also doesn't move anything. Yeah, I don't know how to fix the ground. Let's just see. Maybe if I do this. Nope. Let's just get 5 volts. Oh, that did it. So right here, it should be 5 volts. Oops. All the way up. Hold on. Okay. That's not right. Yep, that's not correct. Okay, right here it's saying it's 6 volts. Okay. So I think it's just because it's offset. Which I'm not sure how to fix. I'm pretty sure it has to do with these pots over here. Not pots. These capacitor trimmers. Let's see. Okay. Display controls. Sensitivity, probe, oscilloscope mode, readout. Probe calibration, that's what I needed. Yep, it is the capacitor trims. Unconnected to signal. Okay, we'll connect that there. So next up it says black unclipped, sensitivity 2.1. Times 5. Switch to AC or DC. Oh geez. Just time. So this one needs to be 0.2. Oh, we're seeing stuff. Oh god. 0.2 milliseconds. Okay, we're doing stuff. So it says that C4 with a small screwdriver, sharp rectangle in photo C. Okay. Says sensitivity. Okay, let's do this first. So now I can change over here. Oh, that's the wrong one. Wait, no, that is C4. Okay, that's 2. Yeah, I'm guessing like that. And then what else does it say? Switch to 1. Okay. I think it may just be something wrong. Oh, 0 line alignment. Corresponding does not match. Easily fix. 0 line adjustment. First set the couple to ground and press select button. Okay. Alright, that's what I needed. That is what I needed. Sometimes you just gotta read. Right? Alright. That was my bad. Then it says select button, VPOS indicator. Don't know what VPOS. Voltage POS. Highlight it and hold down OK for 2 seconds. Okay, I think I know what this means. Position, there it is, and then 1, 2. New release OK button. Running 1, 2. It held. So I don't think that is VPOS. Trigger slope. Parameter adjustment. Let me read some more. Find out what voltage position. That's what it stands for. You'll set line when you release. Okay, let me try this one more time. So that's the voltage position. I press and hold for 2 seconds. I think I held for too long. But okay, 1, 2. Find 0 line. All right, I'm doing something wrong. Here. Alignment. First, set the couple switch to ground. Then press select button to highlight it and hold down OK button for 2 seconds. Does it save the settings? Okay, I think it does save. Okay, maybe it's not that. Don't know what that does. Oh, horizontal position. Trigger level indicator. Reset. Oh, there you go. 1, 2. There we go. There you go. I found it. It was the wrong side. Okay. What happens if I probe the ground? Oh! I did it again. I did it again. Alright, cool. Everything's saved though. So now I do that. Nothing. Because it's on the wrong setting. Nope. Because 2.1. Uh-oh. Oh, because that is not the right probe. That is literally not the right probe. There's a right probe. There you go. Okay. This one looks different. How do you... Triggered. For some reason it's triggered. Okay. Alright. What happens if I OK to that? Let's hold. Normal. Sing. Auto. Trigger mode. So the peak is 3 volts. Oh, geez. Oh, there you go. Okay, so it's pretty shaky. Grab this. How are we doing on battery? Not too great. What? Oh no. 7 p.m. What time is it? Oh, I'm so sorry, creative player. Oh man. I don't know what I was doing. I was probably too focused. R.I.P. the homie. For some reason I'm not able to grab this one. This one I am. This one not so much. That's weird. Let me try and get a better angle. Nope, definitely cannot move that one. This one easy peasy. This one not so much. Oh, What the heck? Ooh. That's really pretty bad. Alright. So I stripped the trimmer. Oh, flathead's way better. I think. Maybe it's not even doing anything. Just keep spinning. Ah! I think I stripped trimmer pot. Looks decent. It's pretty staticky though. I'm not really able to change it though. Trimmer pot's not working. Now there's that one. Oh. Okay, well, it works. Let's see. Wait a minute. Let me check the voltage. Okay, if I hold, yeah, you can. Oh, it's a little low. It's around there. Let's see, 3 volts. All right, so now if I get a separate power supply, and connect grounds. Yep, there we go. Okay. Ah, not again. All right, so now this time it's reading voltage coming in. You can see turning it up and down. That's pretty cool. Let's see. Let's try and clean this up a little bit. I think the trimmer pots are kind of a lost cause. The ground is a little off, so in order to fix that, I need to select over here, hold it for 2 seconds, and then now I can move it. I'm going to move it up a little bit, just like that. And then press OK, and should be good now. One other thing I want to just check before ending. Wait, should I? Let's see. Yeah. Let me select over here. Okay, you can move. I don't know how much it saves, but it does look like it saves a fair bit. Oh, it saves a lot of, what would it be called? A lot of the signal. So you can see the most updated, I guess. And then here's the memory, the backlog. So pretty cool. Not too sure about the signal. Seems like I can clean it up. But it works. It works. That's all that matters. It works. One last thing I kind of want to try. I guess why not hook up the micro USB? Do I even have a cable for... I don't even have a cable for this. This is this micro? I think this is macro. So it's too outdated. I don't even have a cord. That's a rip. Another thing is it has these spacers, which I'm guessing just go in here on the bottom. Little standoffs. Maybe missing one. I do think I am missing one. I may have just misplaced it. Well, that's pretty much it. There it is. The last little spacer. That's complete. So pretty dope. Definitely may be useful. And I will try. Let me try and read a signal. Oh, I'd have to. Yeah, I'll save that for later. But yeah, that's pretty much it. You guys are watching after the fact. Thanks for watching. For the person watching right now, thank you for watching. And yeah, I'll be back probably Friday. And not sure what I'm gonna be doing. Maybe mess around with this a little more. Probably need a 3D print something for it. It's kind of dope that it's also like just handheld. So I can just go around probing stuff. But yeah. Bye-bye. Oh, I'm gonna wait till 5:15. Then it'll be even Stevens. I also don't know how to end. But look at the door, look at the door.